Shabam. Aw, yeah. Word problem. We love us some word problems. Okay? Now, oops, I was going to do this one first. There are two formulas that you are going to need to kind of know, just have in the back of your mind just in case. The first one is, whoa, give me something right with your lens, is A equals P1 plus R divided by N T power. Okay? That's a normal compound type thing, or when things get applied. So, like an interest type problem would be this one, a compounded interest. So A here is the amount, A for amount. P is the principal, that's your start. So that's your starting value. R is your rate of change. Normally, it will be in a percentage form. So you need to convert that percentage to a decimal form in order to apply it in the particular problem. N is the number of times that you compound something. So, for instance, the number of times that the bank applies interest to your account would be a compound. If we're talking about a problem dealing with certain days, like I'll just make something up. Coronavirus spreading over the course of 3 days. So the day would be a compound day, kind of a deal. Okay? And you want to do it over the course of like a week or something like that. And T is our time. Okay? So T is time. Okay? That's one. The other one that we have is hurt. Oops. Whoops. I like hurt. Hert is for continuous compounding. A equals hert. P e to the RT power. Okay? Where P is our starting value, E is E, it's in our calculator, R is the rate of change, and T is time. But this one is for continuous growth or decay. On top of that, you might get a word problem, and wink, wink, nudge, nudge, there's a word problem not only on your quiz for tomorrow, but there's one on the final. Okay? All right? Wink, wink, nudge, nudge. You might get an actual equation given to you in the particular problem, and then you would just use that equation. Okay? Okay? So the amount of toxic fumes measured in Stanke units, or SUs, left in the family truckster after the road trip to Florida can be modeled by F of H, fumes per hour, equals 2,000 times 0.87 to the H power, where H is the number of hours after we got home. So the question A says, how many fumes were there in the van when we got home? Okay. So when we got home, that's how many hours since we got home. That's what? How many hours since we got home when we got home? 0 hours. That's the 0 hour. So H here is equal to 0. So we are going to put 0 in for H, and we're going to calculate F of 0. 2,000 times 0.87 to the 0 power. What's anything to the 0 power? Anything to the 0 power. Anything to the 0 power is 1. Okay? So 0.87 to the 0 power is 1. What is 1 times 2,000? 2,000. So there are 2,000 stanky units in the van when we got home. One day later, 24 hours later, how many stanky units are in the van? Well, that's a great question. What's my H value? 24. So now I'm going to plug 24 into, so I'm going to find F of 24 by saying that's equal to 2,000 times 0.87 to the 24th power. Need me a calculator. Side note for your final, it's probably going to be beneficial to you to have a calculator, some scratch paper. Well, I shouldn't say that because you guys have to send me pictures of your work. So you're going to have a notebook and a piece of paper or something like that, something to write with. 2,000 times 0.87 raised to the 24. What do we, anybody? What do we got? How many stanky units? Let's round to 3. 3 decimal places? 712. Agree? Yeah. If the human nose can't detect a smell with a stanky unit value lower than 7.8, when will the van return to its normal smell? Well, now here in this one, the difference is that, let me bring back F of H equals 2,000 times 0.87 to the H power. So now what this is saying is that F of H is equal to 7.8. So I'm going to plug that in here. And I need to now find the hours that it's going to take to get to 7.8. Well, that's back to last week, Thursday and Friday. It's an exponential. I need to isolate that term. So I'm going to divide both sides by 2,000. And that's going to give me, I'm just going to leave it at 7.8 over 2,000. No need in actually doing that math and rounding early. Let's just keep it like that. So we're there. Now we can switch forms with it, correct? So this would switch to log base of 0.87 of 7.8 divided by 2,000 equals H. So we do log, open parentheses, 7.8 divided by 2,000, close parentheses, divided by log of, open parentheses, 0.87, close parentheses, equals. Okay? And we should get I get H here equaling, 39.830 hours. So just under 40 hours after we get home is the van returned back to me. Agree? Yeah? Okay. I'm guessing that you guys are all going on blind faith because I didn't see anybody use a calculator on that one. So I'm guessing you guys are all going on blind faith on mine. Hopefully you understand how to, to do that on your particular calculator. So, okay? Because every calculator is different. Some you can see what you're typing in, some you can't see what you're typing in. Here, can you see what you're typing in on yours? Yeah. You can? Yeah. Because then if it didn't, then it'd be different steps. Okay? Try this one in here and out there. Try this particular problem with A and B. So we're going to use that formula right there. When a plant or animal dies, it stops acquiring carbon-14 from the atmosphere. That's actually true. Carbon-14 decays over time with a half-life of about 5,730 years. That's actually true. So this means it takes 5,730 years to lose half of its carbon-14. That's how they actually date that when they figure out how old an artifact is or something like that. They look at the carbon-14 left in it and they figure out how much is in it. Okay? So the percentage P of the original amount of carbon-14 that remains in the sample after 2 years is given by this equation. Okay? What percent of the original carbon-14 remains in the sample after 5,730 years? 50%, right? Okay? Because it's a half-life, yeah? So that one we didn't have to do any math with. Had we done the math with that, we would have said P, the percentage left, is 100 times 1/2 to the 5,730 divided by 5,730. Well, 5,730 divided by 5,730 is 1. 1/2 to the first power is 1/2. 1/2 times 100 is 50. Okay. Next one. What percentage of the original carbon-14 remains after 2,000 years? Well, so now we're going to go P equals 100 times 1/2 to the 2,000 divided by 5,730. So we've got 100 times 0.5 raised to the 2,000, and I get 78.511%. Agree? Okay. Love it. There's one more question down here. Okay. Oops, there's two more questions. What percentage is after 20,000 years? So now we would go that's 2,000. That's 20,000. And I get approximately 8.898. Yes, ma'am. Sure. And when will it have 1%? So this is one of those where we gotta actually do some solving now. So now we're gonna say that 1 is equal to 100 times 1/2 to the t divided by 5730. So I'm going to divide both sides by 100. That's going to give me 1 over 100 equals 1/2 to the t over 5730. I switch forms with it. So that's going to be log of 1/2, log base 1/2 of 1 over 100 equals t divided by 5730, not 5750. Times log base 1/2 of 100 is t. So I get t here is 38,069 years, 0.296. Okay. Yeah, we don't need to. There's not one like that on the test. So, all right. So, what you got going forward is you've got any and all missing. Get done. I will tell you. I'll flat out tell you. I had somebody turn in week 1 homework this weekend. Okay? Not worth a lot, but it's still worth something. Okay? So we got that. And you should have gotten a slurry of emails this weekend from me. Because yesterday I went through all of the stuff that was due and sent out reminders to people that had missing stuff on that. On top of, for some reason, I can only send it to your parents, but on top of that, I sent a list of missing out stuff to your parents too. Okay? So any and all missing work, that should be done. So that includes the formative from last week. So I don't need to put that in there, or the homework from last week, because that's still in there too. All right. So then on top of that, you've got your Unit 5 quiz. That will open up this afternoon. We want that done by Wednesday. Okay? And then you've got final review. And you've got your final. That all those two by Friday. Hard deadline. Friday at 3. Hard.